Inverse of function from graph. So this time we have a graph here of parabola, and you need to find inverse of this function, rather sketch it on the same graph. So the question is, sketch inverse of the given relation. Is the inverse of the given relation a function? How can you predict your answer of the above question from the graph? Write domain and range of the inverse. So I'd like you to do this question and then look into my suggestion, right? So as I explained earlier in the previous video, what we will do is we'll reflect this graph on a line y equals to x. So I've already drawn a line y equals to x. This is going to act like a mirror for us, and reflection of the given function on this graph, on this line, will result into inverse of this function. Okay, so we'll do that. Now there are a few invariant points. Let me highlight those. The points which are going to lie on y equals to x. So intersection of graph with the line y equals to x will give result of invariant points. So we can highlight those first. Now we can select more points to sketch a good graph. Now for example, this is a nice point to select. So we can start from here. So if you go diagonally, you go 1, 2, 3 units. 1, 2, 3 units. So that becomes corresponding reflection of your point. Let me say this point is A, then this point will be A dash, correct? Now similarly, we can have another point like this, and let me call this point as B. So it is 1 unit away, so it will be 1 unit here, and let me call this point as B dash, correct? So in a way, we kind of got our graph on this side, right? You can select more points, but I will connect this and draw reflection of the left side of our graph here. So it is kind of looking like this. Oops. So it should have gone from here, so let me just draw like this. Okay. Now similarly, we will select some points on the right side of the graph. Let's say, so we already have a point here. So origin is also a point, which is point C for us, and then this D remains there itself. So D and D dash are same points, and here is point E. So we'll reflect it is diagonally 1 unit away, so we get that point as E dash, right? So we can join these points, and that is how. So inverse of the given function is the one which is shown here. It's kind of a square root plus and minus. Do you see that? So that is how you can get inverse of a function from the graph. Now the second part is the inverse of the given relation of function. So this actually fails vertical line test, and therefore inverse is not a function. But could we really find it out? So the third part is, how can you predict your answer of the above question from the graph? So in the graph, if you draw a horizontal line, so you'll see that the horizontal line crosses at 2 points. That means more than 1 point, right? So when you will find inverse of this function, then a vertical line will also cross at 2 points. Since the vertical line will cross at 2 points, it will fail the test for function. Therefore, you could always test whether the inverse is going to be a function or not using horizontal line test. So remember that. So we have horizontal line test to check if the inverse is going to be a function or not. Now the last part is write domain and range of inverse function. So you can see domain here is equals to x belongs to real numbers, so that x is greater than or equal to 0, right? And the range is that y belongs to real numbers. Well, do you see a relation between domain and range of the function and of its inverse? Let's write down domain and range of the function itself. So for the function, the domain is what? Let me write. So this is for inverse. Domain range, right? And for the function, the domain was all real numbers, right? So let me write for function, domain is x belongs to real numbers, and the range was y belongs to real numbers, but y has to be greater than or equal to 0, right? So you see, domain and range actually flips. So the domain was all real numbers, which changed to range for the inverse. And the range becomes the domain for the inverse. So that is kind of a relation which always happens. And that has to happen because since another way or the real way of finding inverse of a function is to swap. If coordinate x and y is on the function, then the inverse coordinates will be y and x. They flip. By reflecting on y equals to x, we are actually flipping, right? That's the transformation which we are doing. And therefore, since you flip x and y, you actually swap domain and range. So that is how we can connect all these things together and understand inverse function. Inverse of a function, I should say, because inverse may or may not be a function. Okay? I hope you appreciate all these things. Thank you.